guys, welcome back. So in this video we're going to be going over the product rule, which I do know that your book covers the product rule and the quotient rule together, but we're going to go ahead and cover the product rule first, kill it, do a lot of practice on it, and then we're going to move on to the quotient rule. So let's go ahead and get started. So first things first, when do we actually need to use the product rule and why is it even there, right? So the product rule is used when two functions multiply or divide. Let's think about the name, product rule, product. Product is when two factors or two things in math multiply, right? So we're going to go ahead and circle multiply. So whenever we have two functions multiplying, we go ahead and we run to the product rule. So if you guys remember, we had properties for addition and subtraction, which when we had two functions adding or subtracting, we would just take the derivatives and add them or subtract them individually. But we never had anything for products or for multiplication, right? So in this case, this is what we use when we have two different functions multiplying. So before we get started talking about the actual product rule, let's talk about these babies and why you guys may think that they're here. Well, the only real reason why I can say they're here is because babies are the product of us, right? So I want you guys to think about babies when you guys think about the product rule. And that is not the real reason. The real reason is because as sad as I am to admit this, math is kind of boring. And I never really get to put awesome pictures on my videos, so I thought this was a pretty good opportunity to throw in a picture of these awesome babies. And come on, look at them. They're pretty irresistible. I don't even like babies that much. But let's get back to the calculus. So here we have that the product rule, we're going to write it as that a function h of x, just some random letter h of x, is going to be defined as f of x times g of x. So in this case, f is going to be a function, g is going to be another function, and they're multiplying each other, right? We have two functions multiplying. So then we're going to go ahead and say the derivative of this is going to be, the reason how you're going to be doing the product rule is that you're going to do first the derivative of the first function, which is f, and then you're going to multiply by the derivative of this, and then you're going to multiply by the second function without deriving it, right? And then we're going to have plus the derivative of the second function, and we're going to multiply by the first function. So the idea here is that we never have the same function or two functions being derived, right? So we always have f and g, right? We never have f and f or g and g. We always have f and g, and only one of them is being derived, right? We're only deriving one of them, right? So in the first, before the plus, we have f being derived, which is the first function being derived, and then we multiply by the original, just g. And then we add it by the second one being derived now, the second one being derived by the original of just f. So here you guys can see that you're never using the same function on the same side. You're always using f and g interchangeably, and then you're only deriving one of them, f or g, right? Here's a good way to remember it. And you always start off deriving the first function. So if you kind of just memorize the fact that if you're deriving the first function, then that means that the second has to be the original, because you never use the same function or derive two functions in one term. So let's go ahead and just do a bunch of these examples, and by the end, you guys are not even going to think about the rule, are just going to do it automatically. So let's get started with example 1. So here in example 1, you're given f of x equal to 2x. So you may think these are not two functions, right? You're like, man, is there two functions you're multiplying? And you're going to say no, because you just think about 2 and x as just a number and a function, a constant and a function. But if you guys remember, a number is actually a constant function. People just tend to forget that, and it's okay. But now I'm going to show you guys that although 2x can be found by doing the whole coefficient rule, right? Which means that if I find the derivative of 2 of x, I'm going to use the coefficient rule, and the derivative is just going to be the coefficient of x. So the answer is going to be 2. You guys see how the answer of this thing is just 2 without using any product or anything here. The answer is just 2. But it works for this very simple example. It's a very simple example. And let's get real. This is never actually going to come out in your test. You're never actually going to be tested on finding the derivative of 2x, right? That's like way too easy. Unless your professor's just drunk all night and just like forgot to write some crazy extra polynomial that comes behind this 2x. So let's get started on how to actually use the product rule on this problem, right? So we're going to say that the two functions here, let's say we're given 2x, right? Our first function is going to be 2, and our second function is going to be x, right? And how we do the product rule is that let's say we have to find the derivative well, let's call this h of x, right? So we match our box there. H prime of x is going to be equal to the derivative of the first times the second plus, for product, multiplication goes with the plus, and we're going to now derive the second and just multiply by the first, right? So I did the kind of the color combination here so you guys know which function to use. So in the first one, in blue, we're going to derive the first function. The derivative of 2 is 0 because the derivative of any constant is just 0. And the derivative of x is, we don't need to derive x. That's right, because we never derive we never derive two functions in one side of the plus. So what are we going to write here in this green? We're just going to write x. Now we're going to have plus, and now in the second side, in the right hand side of the plus sign, we're actually going to derive the green function, or the second function, which the derivative of x is 1. Good. And now we're going to write in the blue, so since we already derived a function, the green function, the second function, we already derived the function that we're going to put now multiplying to this is not going to be derived because we already derived the function. And we can only derive one function on one side of the plus sign, and we always use two different functions. See? So here we have blue function, green function. Blue function, green function. Here we have derived, not derived. Derived, not derived. So it passes our check of making sure the functions are different, and also using two different functions. Two different functions and only deriving one function at a time. So let's go ahead and finish this example. So 0 times x is just going to cancel and just going to give us 0. And then 1 times 2 is just going to give us 2. So I do know we went to this long, painful product rule to find the answer to be 2, although we found it here much faster and much more efficient. But I just wanted to show you guys that the rule works, right? That it's a valid rule. And obviously you're not going to use it for 2x, but you're going to go use it for more complicated functions, right? So let me give you guys an example of a little more complex function that you would have to do here in example 2. When we have f of x is equal to x plus 1 times 2x plus 1. So originally what you would have to do for this is you would have to FOIL, you would have to distribute, you would have to combine like terms, and blah blah blah. So it just takes way too long. So what we're going to do is we're going to jump into the product rule, and we're going to go ahead and we're going to do with red and blue. Actually, let's stick with blue and green, right? So blue, green, green, blue. Oops. Blue plus. And we're going to have blue. So now we start off by deriving the first function, right? So we take the derivative of the first, which is just going to be 1, right? And then now we multiply by the second, which is just 2x plus 1, the second. And then now we're going to derive the second. The derivative of 2x plus 1 is 2. And then we're going to multiply by the first, which is x plus 1. So see here, we did no foiling, we did no distributing, we did no combining like terms, we just went boom, straight into derivative, right? So now what we do is we kind of just clean it up a little bit, and we're going to just rewrite this as f prime of x equal to, this is just 2x plus 1, because that 1 doesn't really affect anything. The 1 doesn't matter, just 1. And now this 2 here is going to affect things a little bit, because we're going to distribute the 2, and we're going to get plus 2x plus 2, and then we're going to combine like terms. So we're going to have 4x when we combine the 2x and the 2x, and then last we combine the 1 here and the 2, and that gives us plus 3. So our final answer is 4x plus 3 when we find the derivative of this. So you guys see how this is actually a little quicker than actually having to distribute things and all that. And that's why we have the product rule, and is used over just having to expand and using the long, boring power rules. It just gives you much more ability to do different functions, right? So the idea is that you can deal with any function And we're slowly going to build up on that. So now we're going to go to example 3. Example 3. In which, I'm not going to lie to you, it becomes a little bit of a pain. Because here we have something that we don't like. When we're taking derivatives in this chapter, we're going to run into a very annoying problem. And that is going to be the radical problem, right? So you see this radical here just gives me a bad taste in my mouth when I look at it. And I don't want to have all these radicals always in my derivatives. So what I'm going to do is, I'm going to make sure that I don't use radicals. So before I even start deriving, before I even use my product rule, I'm going to go ahead and change it from a radical to a exponent. And that's correct. We always derive an exponent form, and we never worry about radicals. So this right here, this x squared plus 2 has no radicals, so we're good. And then we're going to change this radical of x to x to the 1/2 minus 1. So you guys see how much we use this radical x to x to the 1/2. Or any radical, it's always just to the 1/2 power. It happens so much in calculus, it's just almost like all the time, right? So let's go ahead and jump into the derivative. Okay? So remember, we're no longer doing the whole distributing thing. We're jumping into two factors right here, multiplying. Factor of x squared plus 2, factor of x to the 1/2 minus 1. And we're going to go ahead and jump into it and do the derivative. Using the product rule, because we have two products multiplying. Boom. So I'm going to keep being traditional, and I'm going to go with my blue and green. Right? So I'm going to go ahead and take the derivative of the first, and the derivative of x squared plus 2 is just, you guys are based on this power rule stuff, and it's going to be just 2x. Boom. Good job. Now we're going to go ahead and jump into just rewriting the second term, because if you guys remember, we never derive twice on the same side of the plus sign. So we're going to have x to the 1/2 minus 1. Okay? And now we're going to go ahead and derive the second function, right? And how do we derive an x to the 1/2? It is still power rule, so we're going to bring down the exponent. So we're going to have 1/2 x. We subtract 1/2 minus 1, and that gives us negative 1/2. And then minus 1 just doesn't matter. So since we already derived the green function, we're going to go ahead and just rewrite the blue function. So we're done with taking our derivative, right? We're done with our derivative. The only problem here is our exponents, right? So there are two big no-nos to our exponents when we are giving the derivative, right? Not when we're computing. When we're giving the derivative, when we're just simplifying our derivative, we can't have one, negative exponents. So let's write that here. So we don't like negative exponents, right? And then we also don't like fraction exponents. So that's when I'm giving you the answer. So this is in f prime of x. So we don't like negative exponents or fraction exponents. And here I actually have both of them. I have a negative exponent right here, and that same exponent is a fraction, and then here I also have a fraction. So I need to get rid of these two problems. I'm going to first start off with the negative problem. So the negative problem is going to be taken care of in a second. When I'm going to have, I'm just going to write everything in red already. So 2x. This is still going to stay as a fraction just because I want to take care of everything at the same time. And here I'm going to have 1/2. The negative, I'm going to get rid of it by just bringing it to the bottom. X to the 1/2 on the bottom. Times x squared plus 2. Right? So my last thing that I'm going to do is I'm going to go ahead and get rid of, so now that I'm done with the first part of getting rid of negative exponents, I'm going to go ahead and do the fraction exponent problem. So I'm going to go ahead and get rid of these right here, this 1/2 and this 1/2. And once again, we deal with the x to the 1/2, which is radical x. It just keeps coming back every time. So we're going to go ahead and have an equal sign. And we're going to say that it's going to be 2x times radical x minus 1, no longer an exponent, plus here we're going to do a lot of things at the same time. We're going to write our 1/2. We're going to have radical x on the bottom, and then we're going to have this x squared plus 2 on the top. It's just going to multiply. So we're just going to have x squared plus 2 here on the top. And that right there looks, I'm going to actually move a little bit. So that right there actually looks pretty good because we have no negative exponents and we have no radical exponents. So let's go ahead and do some practice problems on how we can keep doing the product rule and applying all these little algebra tricks here and there to make sure our answers look simplified or nice. Alright? See you guys next time.